Okay, welcome to the part 2 series, and we're looking straight at dimension. Now, there's basic fundamental units, and one of the fundamental units we have is length. We have length, we have mass, we have time, we also have current, current, we have temperature. You've been taught fundamental and derived quantity. We have luminous intensity. This is just only trying to tell you, it's just, I can simply call it light. Then we have amount of substance. Now, these are the basic, it could be seven fundamental quantities. Amount of substance, amount of substance. Now, these are the basic fundamental quantity. And this is from this fundamental quantity we use in deriving dimension. But first, we'll look at its SI unit. Let's look at its SI unit, and from there we now give the dimension. The SI unit for length is meter. The SI unit for mass is in kilogram. The SI unit for time is in seconds. The SI unit for the SI unit for sorry, I just had to use a different color. The SI unit for length, and like I said, mass, kilogram, seconds, and that of current is ampere, and temperature we know is in Kelvin. Luminous intensity is the candela, and amount of substance is mole. Now, these are the basic SI units of the seven basic fundamental quantities. Now we're going to look at its dimension. Look at the dimension. Look at the dimension. Then from there we'll proceed answering dimension problems. Now the first dimension, length is dimension is L, kilogram. Mass dimension is denoted as M. Time dimension is denoted as T. Dimension of current is denoted as A. The dimension for temperature is denoted as K. These are the five basics that we'll be using in handling issues on dimension. Now, let's look at there are two tricks in finding dimension problems. And the first trick is we're going to use what we call the SI unit method. SI unit method, which is the first trick I'll be introducing. In solving dimension problem. Now, for example, they ask you what's the dimension for velocity? Dimension of velocity. And then I ask what's the dimension? The dimension for maybe area. Now, you use the SI unit method, you should put in the back of your mind that velocity, its SI unit is in meter per seconds. So the easiest way to interpret this is simply look at the dimension for it, and we know that the dimension for meter, which we look at here, this is the SI unit, this is the dimension for meter. Look at the line connecting them. These are the lines connecting them. So whenever we see meter, we replace it with what? Its dimension. So when we look at meter, we're going to use L. When we look at seconds, now we use T. Its dimension is T, and we have a -1. Now area, the formula for area is meter square. So the meter here is dimension is L, so we replace it as L square. Now if you're given another problem like acceleration, we know acceleration SI unit is meter per second square. Simply using this simple analogy here, we're going to have L T minus 2. This is the most easiest method of solving dimension problem, but we are going to look at the basic one that maybe I from my own word of experience, that I can say it is well approved, especially for those that have enrolled for the Ijmb program. This method is all right, but the marking scheme or the marking system of Ijmb may not score you well with this method. So the second trick, which is the use of formula or definition methods, and I will be carrying you through that process. And if I'm to give my own advice, I'll advise you to use the formula or definition method. Let's look at the formula or definition method. Example, if you are given an examples of this, find the dimension of the following. Now, how do we find dimension of the following? Now, using this second trick, it's very simple. You should know that area is equals to what? Length times breadth. Okay, it is length times breadth. The area, this is a container. This is a container containing water. Okay, this is the area, this is the length, and this is the breadth. Now, if it is for volume, you know that this is a container having three shapes, three dimensions. So we're going to have a length here. We're going to have 1, 2, 3, which is signifies three lengths, which is going to be L, 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 which are all in meter, which is meter cube. For the area, length times breadth, which is all in meter, which is meter times meter, which is going to give us what? L times L, which is L square. Now, this is how to handle that of area. Acceleration, we should know that acceleration, by as well defined, acceleration is the change in velocity over time. First, we've mastered the definition, change in velocity over time. But we should not forget that velocity, change in velocity, is supposed to be displacement over time. Okay. Now it is expected that you put it like that, but displacement is change in velocity over time. Now we take this and put it here, and we're going to have acceleration is equals to what? S over t over t. Okay, we've replaced the change in velocity, this change in velocity, with x over t, because that is what change in velocity means. So now we look at x is in distance, which is in meter, distance over time. Okay, displacement over time, which is distance, and distance is meter, and time is what? In seconds. Okay, over the time again is in what? Seconds. Now we look at it. What will be our next step? We notice that we've changed it now to its unit. Now we now change it to its dimension. Now you should not forget that changing it to its dimension, meter is represented with L, seconds is represented with T, divided with another what? Seconds here. And we take an inverse, and taking an inverse, we're going to have L over T. Now an inverse is, you when taking an inverse, the multiplication sign comes in. It's among the rules that you ought to know as a student, over 1 over T. Now you ought to now have L times 1, T times T, which is going to give us L over T square, which can still be written as LT minus 2. Remember, t minus 2 is equals to 1 over t square from the principles we studied last time. And if you look at L times 1 over t square, now, okay, it's still going to give us L over t what square. So this thing, you should not be confused. They are all the same. Let's take a look at force. Force, if you are using the first trick, you discover that the SI unit for force is Newton. That is why it may not really work. But using this second trick that we are working on right now, we know that force is equals to mass times acceleration. And we know that the SI unit for mass is kilogram. And like we've done already, acceleration, SI unit is what? Meter per second what square. So it's simple to just convert. Kilogram, its dimension is what? Let's put it so that it can be very clear. Its dimension is in kilogram. Its dimension is what? M, which is presenting mass, times the meter. Its dimension is L. Seconds is T minus 2. Sorry, T minus 2. This is going to give us what? M LT minus 2. And I love students to carry out and comment in the give me a comment if you are confused. And also I want you to like, I want you to share, and also subscribe. And I'll be giving you more to do, more student work to do. And I want you to try velocity, and also I want you to try this number 6 to try the dimension for momentum. And give me a reply in the comment section. Like, share, subscribe. Reach out to other Ijmb students or A-level students. Thank you very much. Now, next meeting, we'll be looking at um, the two uses of dimension, which is to what? To confirm if an equation is correct and also to derive equation. Thank you very much.